Learning to read liquid volume in graduated cylinders or burettes is an essential lab skill. But once you've mastered that skill, reach for PASCO's wireless drop counter to achieve fast and accurate volume readings. When paired with a pH, conductivity, or oxidation reduction potential probe, the drop counter lets you say goodbye to endpoint overshoot during titrations. PASCO's wireless drop counter comes with a charging cable and everything you need to set up a drop dispenser system that works in place of a traditional burette. But a traditional burette also works great with the drop counter. The drop dispenser system includes a solution reservoir, clamp, 2 stopcock valves, and a drop tip. Both stopcock valves are hand-tight, and valve controls are both accessible. The valves are open when the controls are vertical and closed when horizontal. Just like a traditional burette, I rinsed the syringe reservoir assembly, including stopcocks and drop tip, with the 0.1 molar sodium hydroxide titrant and eliminated bubbles from the valves before filling it all the way up. I set the bottom valve to an appropriate flow rate that delivers distinct drops, like this. So I can use the top valve exclusively as an on-off switch to start and stop the flow of titrant. So once you have the drop rate adjusted, it's quick and easy to perform multiple runs. If needed, blot away a hanging drop with a clean paper towel before each run. The drop counter comes pre-calibrated for water-based solutions delivered by the drop dispenser system. If you are using a traditional burette or your water-based titrant concentration is significantly greater than 0.1 molar or you're using something other than water as a solvent, you should calibrate the drop counter. The sensor stores the last calibration. I'm going to perform a strong acid, strong base titration with the pH sensor. I'll use 0.1 molar sodium hydroxide and this 10 milliliter sample of hydrochloric acid, whose concentration I'm going to determine experimentally. I'll add enough distilled water so that the stir bar and the glass bulb are completely covered in solution. Both are fully submerged in the beaker. The micro stir that comes with the drop counter is great when working with small solution volumes, like in a test tube or a 50 milliliter beaker. And if you were to use it, it fits on either the pH probe or the conductivity sensor probe tip position so that the magnet can spin freely. I'm going to just use the stir bar this time. Now arrange the system so the drop counter window is completely over the beaker. If desired, you can add a temperature probe to the second hole on the opposite corner. Now make adjustments so the bar magnet will not strike the pH probe, and at the same time look through the drop counter window to make sure the beaker is still below it. Turn on the stirrer to a slow speed, and then speed up slowly until you reach a speed where you achieve a vortex with no splashing. Add more distilled water if needed to completely cover the glass bulb, and that looks okay. Check your setup one last time and try to aim the center of the vortex directly below the drop counter window. I've already connected both of these sensors in SPARKvue, and I'm going to choose the pre-built titration drop counter experiment. The drop counter is also compatible with Capstone and ChemView software. Now that the setup is complete, let's start collecting titration data. I'm not rushing here because the volume data will only be recorded while drops are falling through the counter window. Once I fully open the top valve to let the drops through, the pH and volume data are recorded on the graph. So I'm moving my drop system And I'm aiming the drop tip over the center of the window. Okay, let's open that valve. And we'll speed through data collection for you. And after just a little over 3 minutes, we're done. So I'm going to turn off the top valve. And let's have a look at the titration data. One way to find the equivalence point is to select the most linear portion of the region where the pH change is most steep. Apply a linear fit where the best fit line intersects the data line. I'm going to use the multi-coordinate tool to generate a volume reading based on the best fit line since there's no data point exactly at equivalence. Looks like it took 10.20 milliliters of 0.1 molar sodium hydroxide to reach equivalence, and now I have what I need to calculate the acid concentration. You can find formal lab investigations for many different wireless drop counter titration options in the experiment library at pasco.com, such as this investigation, either using a pH sensor or a conductivity sensor, or study a redox reaction, look into a double replacement reaction, or investigate water hardness. Look for experiment links in the video description below. Thanks for watching.